Great. All right, so today's lesson is continuation from yesterday. This is still 2.4.2. We're looking at step functions, okay? All right, and one other thing I want to add to this, we are talking about, one other name for this is the greatest integer function. So think about it this way. Everything we're dealing with today is only concerned with whole numbers. Whole numbers is what we are going to be assessing here. So before we even start copying this down, I want you to imagine that you're on a soccer team and your soccer team just got sponsored by Nike or Adidas, even better. So everyone is going to have new cleats, but Adidas only sends cleat sizes that are whole numbers. So you get a big old box that only has 7s, 8s, 9s, 10s, 11s, 12s, right? So some people are going to have really uncomfortable feet, but we have to decide, are we going to decide, okay, if you have a size 5.5, then you're going to have to wear a size 6 shoe, right? That would be the ceiling function because we'd be rounding to the greater number. But if you had a 5.5 and you had to wear the size 5 shoe, that would be the floor function, which is rounding to the lesser number. Okay, so we're going to use a number line just to kind of help visualize this. But that would be a really horrible deal if you got all those shoes, because half the people it wouldn't fit well. But you'd have to make do. Okay, so these are the two ways that we can assign that shoe size to a smaller or a greater size. Okay, so we're going to start on the left side here with the floor function. And the one thing that's different too, it has these two brackets. And this looks very similar to absolute value, but it's unrelated. Okay. What this is saying, you see how it has a bracket with the little L, the little bottom edge here? That denotes the floor function. You can think of that as just the floor. So we have a little dash here on the bottom to denote that we're talking about the floor function. Okay. So it's important to know the name of it, floor function. The equation here is y is equal to the floor of x here. So we have the floor function brackets. We're also going to start to use line segments, and this is the line segment we're always going to have. Always going to have this type of line segment for floor function. Because if you look at this, you can think of it. So say if these were whole numbers, 5 and 6, if you were a 5.5, right, and you got that box of shoes, if it's a floor function and you're a 5.5, you'd wear a size 5. So you see the closed dot, which we'll review in a sec. Closed dot is rounding to the lesser number. So when we round, we want to think about the number line. Rounding to the lesser is towards our negative infinity. Rounding towards the greater is towards the great positive infinity, towards the greater. So let's just stay on the floor function and look at some of these problems right here. So if I have the floor function of 2.3, let's go ahead and put in where 2.3 is, right here. So we have 2.3 positive, right? It's the floor function, so I need to round to the next whole number that's lesser. So what is the number that is a whole number less than 2.3? 2, right? So the answer for floor of 2.3 is 2. See, it's just a clever way to say we're going to round up or round down. I know you're all used to rounding up, you know, if it's 0.5 or greater. But based on what they tell us with these symbols, we're going to know if we need to actually round up or round down. All right. Negative 4.1. When you have negatives, I want you to really be careful. So if you're here at negative 4.1, right? If we round, well, with the floor function, first, are we going to round up or round down to the nearest whole? Let's see. We're going to round to the lesser number here, so negative 4.1. If you're here, we're rounding to the left. We're going to round to negative 5. Okay. 5.7, let's put it on the number line. 5.7. Okay. We know the brackets tell us that it's a floor function, so 5.7 we're going to round to 5. Just rounding down to that whole number. On the other side we're going to round up. So these are the two kind of the two parts of step functions, the two options. So with the ceiling function, it's just the opposite. Instead of the bracket being having the notch on the bottom here, now it's on the top. That reminds us that yes, it's a ceiling. We're going to round up to the greater number. Okay. We also have this line segment, because think of it, if you're here if this is 5 and this is 6, if you have a shoe size, usually it's 5.5, but the box of Adidas shoes only has whole numbers. In this case, it says you would wear a size 6 shoe. It rounds up. So remember, closed dot is the number that's included, so we're rounding up because it's a ceiling function. Okay. So let's look at these. Go ahead and take a look at 7.2. It's a ceiling function, so what whole number are we going to round to?
8.
Negative 1.4. Let's always look closely at the negatives. So here's negative 1.4. We're rounding ceiling function, so we're rounding to the greater numbers that way. So what are we going to round to with this?
Negative 1.
Negative 1. Whoa. That's weird.
Not high.
Then we have 10.7. It's a ceiling function. We round to the greater whole number, so we round to what?
11.
11. Okay. Thumbs up, sideways, or down for figuring out where we're going with ceiling or floor. Yeah, right? All right. So the only difference, the next step that we have to work through is basically covering, move this. Getting sick, no. All right. There we go. All right. So, just a couple reminders. Open dot, not included. Closed dot, we are included. Okay. So closed is filled in. And just real quick, if we look at this graph here, we're going to end up creating graphs that look like this. And it's kind of helpful because we see that the step function does look like steps, right? What do we notice about the step functions? Is there anything else we can kind of notice?
Parallel.
They're all parallel because they are different different values of a y coordinate, a y line. Good. What else? What else can you notice? Just like the shape, where are things located? Is anything lined up? Staggered. Okay. So when you say staggered, I'm guessing, tell me if you're right, that we're going to end up with one right above the other. And this makes sense that we have to count the closed dot for the bottom one. We can't have closed dot here and closed dot here, because that's saying that for my value of x is negative 1, it's equal to 0 and it's equal to negative 1. Okay, we can't have that. So one has to be closed, one has to be open. And we have a stagger right here, we have a stagger right here. With these functions, you're only really going to graph, we're going to plot 3 different steps, and I want you just to add a couple more steps to it. So I can add a step here, go 1. I can add a step here and go 1. And these are all staggered, right? Why do you think that our width right here is 1? Because what are we interested in with this whole thing? The whole thing. We're only interested in whole numbers. So it's going to be set up so that we have steps that are one wide, so that they're always on those whole numbers. Okay. So 2 numbers that are included, closed dot. Here we have 0, 0, 1, 1. 2 that are not included, open. We have here at 1, 2, and 2, 3. Those are just examples. All right. So now we have to graph this, and it's actually going to be exactly the same as graphing any function. But what we have to do is when we get to the step of inputting a value here, we have to just assess it as a ceiling function in this case, right? Once we assess it as a ceiling function and round, then we're just going to add 1, and that's going to be our y value for it. Okay, so what I suggest for a strategy, first off, if it's a floor function, my line segments for my steps are going to look like so, because we're rounding down to the next, the least number here. If it's a ceiling function, my segments look like this.
We don't like the truth, but Max preaches.
Hey, welcome back. We're live on video.
Oh, sorry.
I noticed that too. All right, here we go. Ceiling function. We have the closed dot on the right side because we're rounding up to the next whole number. Our strategy is also going to be finding the points that are closed, and then I'm going to graph and add my steps based on ceiling or floor. Okay, so it's pretty straightforward strategy here. We're going to use this table. This table right here is what we're going to work with. Now, just because we have whole numbers here does not mean that we're going to always end up with numbers that we don't have to round. When we get to example 2, we're going to have to do some more work inside of our step function. But just to start here, let's see. First off, is this a ceiling or a floor?
Ceiling.
Ceiling. So I know with the ceiling, we're always going to round to the greater number. And I know with the ceiling that I'm rounding up to the whole number. So I put my closed dot on the right side because it's rounding up to that number every time. Now let's use our table -1, 0, and 1 and just plug them in. Some of this can be mental math. I'm just going to write it out. -1 plus 1. Is this a whole number already? Yeah, this is already a whole number. So we don't have to do any special ceiling rounding. It's just -1 plus 1, and that's 0. Okay. This is a really straightforward, easy example. We're going to use these x values, but when we get to the next example, it's not always going to work out so that it's just, oh, it's -1. I don't round that at all. It just stays -1. The next example is going to have a little bit trickier process. We have 0 plus 1. 0 we cannot round either, so we're going to go ahead and make that 1. Our last. F of 1, we get 1 plus 1, and that's 2. So we lucked out here. We lucked out here because everything is a whole number. The ceiling function didn't really have us round any value in particular. So now I'm just going to make my graph, and step 2 is to plot the points that you have with a closed dot. Okay. So let's look and see. -1, 0, -1, 0. 0, 1, 1, 2. So I just plot those points. And the thing is, it doesn't matter if this was a decimal inside, so we'd end up with a decimal in here as we plug in x, because the ceiling function would get rid of that and make it into a whole number anyway. So as we plot these points, we're going to end up with some points that we're going to actually put our closed circle on. And then let's look at this. We knew it was a ceiling function, so that our closed point is on the right. So now I already know some information about it. It's always staggered, so it's right above each other. So what I'm going to do is go back here and make my steps. All right. I can make a couple more. So what this is saying is, if you wore a size shoe 2.5, right? Wow. Small feet. If you had a 2.5, you would round because it's a ceiling function, and you'd be wearing a size 3 shoe. Okay. Actually, this is 1.5, so you'd wear a size 2 shoe. All right, have a good picture. All right, what's the hardest part about this? Maybe even like looking to see what kind of problem you're dealing with. It's ceiling, so it rounds to the right, and we're going to end up with these steps. Okay. Then we choose the numbers to use in your table, I suggest these, but you can use others. I just like it because it's by the origin. We're going to plot these points with closed, and then plot your open steps here. We knew the step looks like that because it's ceiling, so we just plot them right there. Okay. All right. Let's try this one. All right, this one's slightly different. What do we see in this one?
A negative.
We have a negative, and we have 1.5.
Oh, floor function.
Oh, good. That's another difference. Good. All right. So, first off, we know that it's a floor function, so we know we are going to be rounding to the lesser number. We also know that our segment is going to look like so, because whatever value you have, you're rounding, if it's a decimal, you're rounding to the lower whole number, the lesser one. So, let's see. Let's do our box. Make a table. -1, 0, 1. All right, so let's see, f of -1, negative 1.5 times -1. Okay. So negative, and we have 1.5 negative. So thinking about this on a number line, if we have negative 1.5, and we are doing a floor function, so we're rounding to the lesser number, negative 1.5 rounds to what? Negative 2. Because it's a floor function, we're going towards negative infinity with that. So altogether we get positive 2 for that. Alright, 0 is really easy. Can we look at 0 and figure this out? I think so. We plug in 0 right here. 1.5 times 0? 0. Nothing around with that. 0. Alright, how about f of 1? We get negative floor 1.5 times 1. Let's go negative 1.5. So now we're at 1.5. We need to round to the lesser number towards negative infinity. So what number does 1.5 round to? We're talking about the floor function.
2.
Just to 1. So watch. 0, 1, 2. We're at 1.5, right? 1.5. It's a floor function, so we know we're rounding towards the lesser numbers. So this is going to round to 1. Honestly, just on the top of the sheet, just put a number line, because it's way easier to visualize it that way. Okay, until you don't need it. Let's see. So we ended up with negative 1 altogether, because that was 1, negative 1. All right. Let's plot some points. 0, 0, right here. Negative 1, 2. 1, negative 1. So now we have to know what step we're going to put in, and we can conceptually think about it. We know that's a floor function. So I know that whatever my values are, I'm always going to be rounding down to the next whole number, right? But also we set this up in the start to know that we're going to use that type of step. So I line them up. Go ahead and jot it in right like that. Okay, so that's how we're going to try to graph every single time. It is going to be a little different when you have a decimal here, and so we're going to round down for shoe sizes. That's kind of one way to think about it. Okay, thumbs up, sideways down for step. Yeah, good. You came in a little late.
Yeah, we came in a little late.
Maybe watch a few.
All right.
Somehow I do, but then I realized we did it. It was good.
We're kind of smaller numbers, but you want to do it? Subscribe on 3. 1, 2, 3.
Subscribe!